Hi, I'm Paul Brodie, back in the shop. We had a snowstorm last week and so we skipped a week. Sorry about that, but we're back. Got things to show you, working on a giraffe bike, and I built a wheel, used black spokes. It's a lot easier to get black spokes these days for some reason at my local shop. That's Velocity Cycles. Okay, so we got the wheel. I bought some bronze for the cranks. The crank arms are going to be made out of bronze, and I had one piece of bronze, and I bought another piece. It didn't have to be this wide. It only had to be 1.5 inches wide, but that's how it came. So I bought this piece, I think $115 plus tax. That's what happens when you're into bronze. I found some old pedals. I got these at a swap meet last year, and the rubber is really quite cracked, so I think these will work fine, or at least they can go on the bike at first. And then I was working on the chain. I had to shorten the chain. It's a skip tooth chain. And I've got chain breakers, these guys, and they don't work because it's old and it's an odd size. This looks like a master link. It's from Germany because it's the only link that looks like that. This is flat, all parallel, and this is scooped out, but it's not a master link. So I need to take out this much of the chain for the length of the chain stays. So my chain breakers didn't work. So what I want to try now, we're going to use the arbor press, and then we're going to see what happens if I can press that without this sliding off or something. So I don't have an extra something like this, and I don't know. I don't understand why this looks like a master link, but it's not. So let's go over to the arbor press and see what happens. Now the worst thing is that it spits out the side or something like that. So I have to try and make it as vertical as possible. Let's see what happens. It wants to bend this, doesn't like that. Okay, I think I need to do some more research on this link and find out any information I can. Okay, we're going to move on. Here's the sprocket that I got off eBay, and it works on the skip tooth chain, and I've got a freewheel. It's a BMX freewheel. It came in, and it's small enough that if I put extra metal on this, I got some DOM tubing here that's going to work. I can make up a sleeve that fits on here. So here is the drawing. On the drawing, here is the freewheel. You can see that I didn't even use a ruler for this drawing. You can see that this is supposed to be this, and there's two pieces that go on there. I make this piece, out of this piece, I make this here, and that fits on over here, because I can't weld onto this. It's got bearings and a clutch mechanism inside. I can't do any welding at all. It's just going to screw things up. So this piece slides over here, and it's going to get machined so that after I grind down half of the sprocket, this fits right into this. So it can't spin at all because there's a machined little pocket for each individual tooth, 14 teeth actually. And then you see here, see that shading? That's where the sprocket goes on, and then it gets brazed on there, and then after it's brazed on there, it gets bored. And so the boring part of the operation is the last part here. See this little notch here? That's where the teeth go into. So that's part of that. Actually, it doesn't go up that much because the last part, this only has to go up I realize I've drawn it wrong now. This only has to go up a little bit, just for on the bottom there, because this part here, it gets cut away on the milling machine on the rotary table. I know it's a lot of talking. This piece here, it's aluminum, and it gets made out of this. It's about 3/8 of an inch thick. And it goes over this side of the freewheel here, and there's little screws, little Allen screws. I think it's a 3mm that's going to work, because it doesn't have to hold much. And there's going to be 5 of the screws. So first thing we do is I'm going to have to cut this out about to where the felt pen mark is. But there's this slot here, and I don't know what's with this slot. So I have to take this, and I have to make it the right size so it fits in there. I got to take off the plating, maybe a little bit of bead blasting. Then I'm going to TIG weld that into there. And then once that is TIG welded into there, then this can get held in the lathe. And it's kind of handy because it's a 9-tooth. In. This is still warm. I can feel it. There we go. A little bit of... Oh, maybe I went too far. I'm going to bore this out now, and then we're going to start working on, I'll call this the hub part of our project here. So this is 2.1 inches. We'll just bore that out on the lathe. And then we'll make this piece so that fits over nicely. And then this is going to get welded on. I think we're going to braze it on. Probably nickel silver. That'll work fine. Let's go to the lathe. It's hard. So we have to heat this up till it's red hot, and then we put it into lime, and we'll work on something else while it cools down. That's how we do it. So that fits in there like that. Okay, there's the first part. We got 15,000 to come off. Okay. I couldn't have planned that one. Okay, so it cut a little crooked, but we got excess, so let's go back to the lathe and finish this piece. this piece here in the lathe, it's basically done. What we need to do now is to go to the mill. This goes onto the rotary table, gets held with a 3-jaw chuck like so, and then we take an end mill and we have to cut out where the 14 teeth of the freewheel go, so that this is how the freewheel fits into here, and the teeth engage. So let's go to the mill for a while. I'm marking this hub here because it's going to get milled for each of the teeth. It's going to get milled 14 different times. And I have to turn the rotary table. I forget how many degrees it is each time, but it has to be pretty precise if you want a good fit. I do. I didn't learn this from anybody else. I just figured it out myself. It's an odd number of degrees. It's 25.714 degrees because you divide 360 by 14. So we go to 25. Okay, so let's have a look and see how we're doing here. It's hard to know if it's going to fit, because we have to do some grinding now. I'm going to put some masking tape around here so we don't get crap into the bearings. And this has to come back to about like that, so it fits into there. And maybe these slots I made with a 1/4-inch end mill. It's a possibility that I need to make it a little deeper. But I think the next stage is to, that's a good fit. I think the next stage is to grind these down a bit. Jeez. Tight fit. So where's the hold up? Look, it's got a little bit of play to it, right? So I just have to press it harder. Oh, I know what I could do. I could put it in the lathe and I could take a little cut right off there. Just if I took a little cut right there. So look, it does fit. We're going to drill a hole there because we have to mount it on an arbor, and then I'll spin the OD, I'll turn the OD on the lathe, and then we can hold it on the 3-jaw, and then we bore out the inside. Okay, we're looking for a sprocket in here. I feel something. Oh, put my hand on it. It's good. Okay, so I'll just blow off the lime, and then we can bore it out. We'll go back to the lathe. Aha, look at that. Very nice. So, you can take off the burrs, and I'm going to get the brazing torch going. What I'm doing here is I'm marking out the 5 holes. It's going to be threaded 3 millimeters. And that's what's going to hold the aluminum piece onto this hub piece. So, I'm going to mark it out. Okay. I substitute the aluminum ring for this, and then I do those same 5 holes again so that the hole and the thread are lined up. That's what I want. So let's see. Pretty finicky little stuff just for a freewheel, but gotta do something. Okay. Okay, so we got the 5 holes in the aluminum ring, the aluminum lock ring. So what we'll do now is to drill these up to the tap drill size and tap them, and then we'll do the silver soldering because I didn't want to have to tap into the sprocket. That metal's really hard. In this situation, silver solder can be extremely strong because it's 2 surfaces that are really close together with a very small gap of a couple thou. And if the silver solder wicks in there, that thing is stuck. So let's do this. See how it's melted right there? So I just wait until it starts to flow a little bit. Add a little bit. See that? Beautiful. I don't know if you can see that wick. bottle boss on a down tube on a bike. Got the cone really, really close. This is different, so all different kinds of applications when you're silver soldering. There we go. We've come around 360. It works out quite nicely. So after the silver soldering, it might have shrunk a little bit. I might have to do a little bit of sanding inside, but this is how it all fits together. You can see how these two threaded holes are closer than the other ones. That's because there's 14 teeth, and this fits over like that, and then the little Allen screw that I have to sand down the outside a little bit, that's where it goes, and then it holds this in. And then the freewheel works. This is the drawing which I made. I was going to show you earlier, but I didn't get around to it. Here's the bottom bracket of the bike, the giraffe bike. These are the chainstays. This is going to be the hub. That's probably going to happen next week. Here's the sprocket right here, like that. That's the red line. And then this is the front sprocket. That's the end of the sprocket, or the edge of the sprocket. And I don't have a long ruler right here, but these guys are right in line with each other. And so what that means is the chain line worked out really well. I'm happy with that. And that is our episode for today. Thank you very much for tuning in. Mitch and I like coffee. Please subscribe, like, share. Thanks again. We appreciate all the views, and we'll see you next time.